Hello students, welcome to class. In this class we are going to learn about asymptotic notations. So let us assume I give one problem to two persons. So for example, the problem is factorial of n. The problem is factorial of n. Now I give this problem to two persons, one is P1, another one is P2. Now so P1 and P2, so both the persons come with the solutions C1 and C2. Now we are going to decide so which algorithm is efficient, which algorithm is best. So how we are going to define that? So for example, so normally we decide that based on the time. So let us assume C1 program completes its execution in 15 seconds and C2 completes its execution in 30 seconds. Now we decide that so C1 is best algorithm when comparing to C2, but that is not correct. Why? Maybe the C1 is executed in i7 processor and C2 executed in i3 processor. That means so based on the power of the processor also the execution speed will be vary. So this is not correct. Now if you are using the same processor, that is also not correct. Why? While we are executing the program, there is some background processes are executing. Background processes are in execution, and based on this also the time will be vary. When we execute the C1 processor, maybe there may be a 20 background processes are executing. While we are executing the C2, maybe there is 40 background processor executing in the same computer. Then also the execution time will be increases. So we don't consider this also. So to analyze any algorithm, we need some mathematical model. So those models are asymptotic notations. What is asymptotic notations? Asymptotic notations are used to represent the complexities of algorithms for a asymptotic analysis. These notations are mathematical tools for represent the complexities. So normally we express the time complexity in terms of n. Now the parameterize the running time by the size of the input is n here. So T of n equals to time required by an algorithm or any input of size n. For example, what is the time complexity of bubble sort mean? Big O of n square. So what is n here? N specifies the size of the array here. Okay, the parameterizing the running time by the size of the input size we specified as n here. N is input size. Now if the size of the n is increasing, then execution time is also increasing. Okay, we have so four types of notations. One is big O notation, omega notation, theta notation and little o notation. We discuss one by one. So big O notation represents upper bound of algorithms running time. So what is the upper bound? So upper bound is nothing but, for example, a person want to reach from one place to another place. This is the place 1 and this is the place 2. How much time is required to reach this place P2 from P1 in worst case? So for example, the distance is 10 kilometers. Within 2 hours, this is the worst time. The maximum time is 2 hours to reach from P1 to P2 place is 2 hours. Now 2 hours is the upper bound in this problem. Now what is big O notation? Big O notation represents upper bound of algorithms running time. By using big O notation, we can calculate maximum amount of time for its execution. This is the maximum time. A person reach from P1 to P2. What is the maximum time? The maximum time is 2 hours. Okay. Big O notation is used to calculate worst case calculation. Worst case calculation. So this is the worst time to reach a person from P1 to P2. Let us assume linear search. Linear search. If we have 5 numbers, let us assume 8, 18, 9, 2, 5. Now what is the worst case? If you are searching for the element 5 or if you are searching an element that is not present in the array, let us assume that is 28. Now these two are the worst cases. So definition, f of n, g of n be two non-negative functions. These two are the functions f of n comma g of n. And here we are discussing about big O notation. Now when we say f of n equals to big O of g of n, there is a condition. If there exist two positive constants c and n naught, these are the two positive constants c comma n naught. The condition is f of n less than or equals to c into g of n for all n greater than n naught. Okay, always the value of f of n is less than or equals to c into g of n. Okay, so this is the graphical representation of big O notation. Here fn and gn, so these two are the functions, and f of n less than or equals to c into g of n for all n greater than n naught. That means, so this is the n value, so this is the n value. Now if you observe that, so this is the f of n, this is the f of n, and this is the c into g of n. Now so f of n here less than, this is the less than from a point, this is the point, so this point is n naught. From this point the f of n always less than or equals to c into g of n. That means, so this is the upper bound here. Let us discuss with one example. F of n equals to 3n plus 2 comma g of n. Now we say that f of n equals to big O of g of n when f of n less than or equals to c into g of n for all n greater than n naught, n greater than n naught. Now substitute here, what is f of n? 3n plus 2 less than or equals to c into what is g of n? N. Okay, let us assume c equals to 4, c equals to 4. Substitute 3n plus 2 less than or equals to 4n. Now consider n naught equals to 1. Now in the place of n we substitute 1. 3 into 1 3 plus 2 less than or equals to 4 into 1 4, that is 5 less than or equals to 4. Not satisfied, not satisfied. Next, n naught equals to 2. 3 into 2 6, 6 plus 2 less than or equals to 8, that means 8 less than or equals to 8, true. So it is satisfied, it is satisfied. Next, n naught equals to 3. 3 into 3 9, 9 plus 2 11 less than or equals to 4 into 3 12. So this is also satisfied. Now what you observe? So this is the 0 1 2 3 4 n naught values, n values. Now after taking the n naught equals to 2, from this point always the f of n is less than g of n. Now this is the g of n maybe. So previous it is okay, but from 2 onwards the f of n is always less than or equals to g of n. So n naught is greater than or equals to 2. Now so f of n equals to big O of g of n. What is the condition? F of n less than or equals to c into g of n for all n greater than or equals to 2. Now pause the video and try to solve this problem and assume c equals to 6. So what is f of n? 5n plus 3, g of n n, 5n plus 3 less than or equals to 6n. We assume that c equals to 6 here. Now so take n naught equals to 1. Substitute 8 less than or equals to 6. Not satisfied. Not satisfied. Take n not equals to 2. 13 less than or equals to 12. Not satisfied. Take n not equals to 3. Now substitute 5 into 3, 15 plus 3, 18 less than or equals to 18. Yes, satisfied. N not equals to 4. 5 into 4, 20, 20 plus 3, 24 less than or equals to 6 into 4, 24. Satisfied. That means if the value is greater than or equals to 3 onwards, we say that f of n equals to big O of g of n, when f of n less than or equals to c into g of n for all n greater than or equals to 3. So next notation is big omega notation. So big O is upper bound, big omega is lower bound. It represents lower bound of algorithms running time. By using big omega notation, we can calculate minimum time for its execution, and big omega used to calculate best case. Okay, previously we discussed that there is a place P1 and P2. So here from reach from P1 to P2, this is 2 hours. That is the worst case. And what is the best case? Maybe in sometimes we reach in 30 minutes. Now this is the best case. So coming to linear search, if the searching element is in the first location, for example 8 in the first location, and you are searching for the 8, then it is a best case. Okay, so big omega represents always lower bound. Lower bound means minimum amount time for its execution. So minimum time, so it is a best case. Okay, now coming to definition, f of n, g of n be two non-negative functions, then f of n equals to big omega of g of n. If there exist two positive constants c comma n naught such that f of n greater than c into g of n for all n greater than n naught. In big O notation, the f of n is less than or equals to, that is the worst case. Here it is the best case, means f of n is greater than c into g of n for all n greater than n naught. So this is the graphical representation. If you observe, after a number, a value n naught, the f of n is always greater than g of n. This is the g of n. Okay, it is always greater than g of n. That we represent as big omega notation. So let us discuss with one example. Here f of n equals to 3n plus 2, g of n equals to n. Now, so f of n equals to big omega of g of n. So what is the condition? F of n greater than or equals to c into g of n for all n greater than n naught. Okay, so let us take c equals to 1 here. Let us assume c equals to 1. Now what is f of n? 3n plus 2. Greater than or equals to c is 1 and g of n is n. Okay, 3n plus 2, so greater than n. Substitute n equals to 1. So 3 into 1 3, 3 plus 2 5, greater than 1. Yes, satisfied. N naught equals to 2. So 3 into 2 6, 6 plus 2 8, 8 greater than or equals to 1 into 2 means 2. Yes, it is satisfied. Next, n naught equals to 3, it is 11 greater than 3, satisfied. Now what is the condition? N naught should be greater than or equals to 1 here. Okay, if the n value is greater than or equals to 1, then the condition is satisfied. So we say that f of n equals to big omega of g of n, big omega of g of n, if there exists f of n greater than or equals to c into g of n, here c equals to 1 and n not equals to 1 for all n greater than or equals to 1. So, next notation is big theta notation. So, big O notation is upper bound, big omega notation is lower bound, and big theta notation is for average. Let us take P1 and P2, place 1 and place 2. From P1 to P2 it takes 2 hours, that is worst case. 30 minutes is best case. 30 minutes is best case. If it is 1 hour or more than 30 and less than 2 hours, that is average case. Okay. Now you apply the same to program also. It represent average bound of algorithms running time. By using big theta notation, we can calculate average amount of time for its execution. Big omega used to calculate average case time complexity. What is the formula here? Let f of n, g of n be non-negative functions. Then f of n equals to big theta of g of n. Big theta of g of n. If there exist three positive constants, previously it is only two constants only, c and n naught, here c1, c2, n naught, such that always c1 g of n less than f of n less than or equals to c2 g of n for all n greater than n naught. So, this is the graphical representation after some point n naught. So, this is the n naught. Observe, the Fn lies between C1 of Gn and C2 of Gn. So, it is represented as C1 Gn less than or equals to f of n less than or equals to C2 into G of n. That is it. So, this is the average case that we call as theta notation. Let us discuss with one example. So, f of n equals to 3n plus 2, gn equals to n. Here I am taking C1, C2. So, let us assume C1 equals to 1, C2 equals to 4. So, what is the condition? So, C1 into g of n, that means n less than or equals to 3n plus 2 less than or equals to C2 is 4 into n. Now, substitute n not equals to 1 less than or equals to 3 into 1, 3 plus 2, 5 less than or equals to 4. Not satisfied. Let us take n not equals to 2. 2 less than or equals to 3 into 2, 6, 6 plus 2, 8, 8 less than or equals to 4 into 2, 8. Now, so 2 less than or equals to 8, 8 less than or equals to 8, satisfied. Now, consider n not equals to 3. 3 less than or equals to 3 into 3, 9 plus 2, 11 less than or equals to, so 4 into 3, 12. This is also satisfied. Now, what we observe? Now, so there are two functions. Now, the n not equals to 2. Now, so from this point onwards, the g of n is lies between g of n, C1 into g of n and C2 into g of n. So, this is n here, okay, and C2 g of n is 4n. Okay. So, after n2 equals to 2 point, from that point the g of n is lies between C1 g of n and C2 g of n. So, we can say that if the n naught value greater than 1, then the condition will be satisfied. Okay. Next notation is little o notation. It is the same order. The function f of n equals to little o of g of n if and only if limit n stands to infinity, f of n by g of n equals to 0. Now this is the example. So f of n equals to 3n plus 2, g of n equals to n square. Limit n tends to infinity. So what is f of n? 3n plus 2 by g of n equals to n square equals to 0. Take n common here, n 3 plus 2 by n by n square equals to 0. Substitute n equals to infinity, 3 plus 2 by infinity by n square equals to 0. Anything by infinity is 0. So the total will be become as 0. Now we say that 3n plus 2 equals to little o of n square when limit n tends to infinity, 3n plus 2 by n square equals to 0. Okay, this notation we call little o notation. In next lecture we are going to discuss about recurrences. Thank you.